Now, just recalling what we did last lesson. So last lesson we looked at exercise 11B, expected value. The notation for expected value is E bracket X, and it is the sum of the X's times the probability of X. So in your table, when you write out your X, which is your outcome, and the probability of each of those outcomes, and when we multiplied X by PX, we get XPX, and then we added them up, and in this corner we had a sum. Now that sum is called the expected value, the one that you find in this corner here. We did this last lesson. So the expected value, expected value of X is the sum of all the X's times the probabilities of those X's. Okay, so notice this is a sum here. So this EX, see, expected value is whenever you're multiplying what you want by the probability. Now, the reason I'm showing you this is that this is an EX and this is sum of all the X's times the PX's. Today, we're looking at variance and standard deviation. Now, if you remember data from stage 5, expected value is like our old mean, what we used to call the measure of central tendency, the mean. Measures of spread, we learnt about interquartile range, and standard deviation in 5.3, right? Now we use, again, standard deviation, but something also called variance, and we have a new formula for that, okay? So variance and standard deviation are measures of spread. To find the variance, so what we're going to do, we're going to do it in a table, and there are 2 different methods for finding the variance, okay? And you will get the formula for both of those on your formula sheet. So to find the variance, we just take the difference of X minus mu of each value from the mean. Now we know that mu was our expected value. So when we work out our expected value down here in the table, mu, what we're going to be doing, oh, that got dirty, is X minus mu for each of those values. We'll get to it in a minute, all right? So we'll be, to find the variance, we just take the difference of X minus the mean, or mu, or the expected value for each value of the mean. This is called the deviation of the value X from the mean. Deviate, if you deviate from a straight line, you're moving away from the line. Once you start deviating off the path, you may have heard that, right? So your difference from the mean is called your deviation, okay? What we do, we work out our score minus the mean or the expected value, and then we square it. So we square the deviation to give X minus mu squared. And the reason we square it is so that we'll end up with a positive value, all right? Because some values might be to the left of the mean and some values to the right. And we don't want the left values, the negative values, cancelling out the ones that are positive. So that's why we square them, okay? So the square will always give a positive number or 0, whether the value is on the left or the right of the mean because of the squaring. And then what we do, we take the weighted mean of these deviations. Now, the way you take the weighted mean of those deviations. Now, the way you take a weighted mean is that you'll multiply these X minus mu squared by the probability, okay? So we'll be multiplying each of those values by PX, probability of X. So the variance, here is a formula. The variance of X is the expected value of the X minus mu squareds. Now, what is expected value? Expected value is when you multiply that X minus mu with PX. That's why I was showing you the other sheet earlier. Look, if you look here, expected value of X is when you multiply the X's by the PX's and sum them. So so we're working out the variance of X, which is like the expected value of the variance. It is the PX's times the X minus mu squared, and then we sum them. But it can be also written like this. So variance of X is the expected value of X minus mu squared. So expected value is when you take the X minus mu squared and multiply it by the PX. I just don't want you getting mixed up between the different types of notations, all right? Now, there is an alternative formula for variance of X, guys. It's the expected value times your score squared, your outcome squared, minus the mean squared. See, whenever it's expected value of X squared, expected value means times your x squared by px. So those two formulas are the same. All right? Now, okay, now we're going to complete the table. I think the best way to do it is just to do an example. All right, let's look at the first way of working out variance. This was when 4 coins were tossed from last lesson and the lesson before. We're just sticking with this example. And you're recording the number of heads. You can get no heads, 1 head, 2 heads, 3 heads, 4 heads. And we worked out the probability of each. And we know that the sum of all the probabilities is 16 out of 16, which is 1. So now we do x times px, and we get 0. What's the next one? 4 on 16, good. The next one, 2 times 6, that's 12 on 16. I'm just going to leave it like that. Again, 12 on 16. Now, we did these last lesson, and then when you add those up, the reason I've kept them out of 16, you get 32 out of 16, which is 2. Now, we already had that. That's what we did last lesson. So this, the sum, so this is the mean or the expected value of x. That's what we did last lesson. Now, that tells us where the center of the data is. In other words, if you toss if you toss 4 coins, we're expecting on average 2 heads, 2 tails. Now, x minus mu squared. So this x minus the mu. So what's that? 0 minus 2. Mu is 2, okay? So 0 minus 2 is negative 2 squared is 4. 1 minus 2. See, because we're looking at the mean is 2. Isn't 0 2 scores from the mean? So the mean is 2. So we're saying that 0 is 2 units away from the mean, and then we're squaring it. If I draw a number line, look, here's my mu, it's 2. And then I've got my other scores are 0, 1, 3, and 4. So here's my mean. So we're saying this is 2 units to the left of the mean. So that's why we do x minus mu. This is my score. 0 minus 2 is negative 2 squared is 4. 1 is 1 score from the mean. So 1 minus 2 is 1 score, negative 1, whatever. It's 1 squared is the score. 1 minus 2 is negative 1. Squared is 1. Yeah? 2 is on the mean. So 2 minus 2 squared is 0. 2 minus 2 is 0. 0 squared is 0. The 3 is here. 3 minus 1. So these are your scores. 3 minus 2 is 1. 1 squared is 1. 4 minus 2. Do you know what I'm doing? Is 2. 2 squared is 4. So it's your score. See, x minus that one's mu. So your x minus your mu, and you square it. Okay. So you add them all up, and what do you get? 4, 5, 10. Now, that is the square of the deviation. Now, once you multiply it by probability of x, it then becomes an expected value. Okay? So this result times the probability. So what's 4 times 1 on 16? 4 on 16. What's 1 times 4 on 16? 4 on 16. 0 times that is 0. 1 times 4 on 16. And 4 times 1 on 16. And you add them all up, and I'm getting 1. 16 on 16, which is 1. So now we can say, therefore, the mean or expected value, which is your mu, is 2, and the variance is the sum of, so this is the variance. It's the sum of the spreads from the deviation squared times the probability. It's that formula. So it's the sum of the x minus mu squared times px. So we've done x minus mu squared times px, and then we've added them up. That's the variance. Now, the way we write that, so look at this. I think you understand this notation. It's the sum of the x minus mu squared times px. But this is the other notation. It's the expected value of the x minus mu squared. This capital E means to take each of these values and times it by px. That's the difference in the notation. And then add them all together. All right? So whenever you see E, it's these values times by px and added together. That's what expected value tells you to do. All right? Now, there is an alternative formula for variance, and you tend to use this formula, I think, if your means aren't whole numbers, they tend to use them, all right? So both will give you the same result, or what they're supposed to, I think. So another formula for variance of x is the expected value of x squared. Now that means you've got to multiply the x squared by px. So when you put an e next to something, it means multiply those values by px and add them together, minus the mean squared. So that formula is the same as this: x squared times px, add them up and subtract the mean squared. So you're only summing those, you're not summing the subtraction of the mean squared. Okay, so what's x times px? Go. I don't think I need x times px, but we'll just do it. 0, 4 on 16, it's not needed. 12 on 16, you don't, oh yeah, you do need it for the mean. 12 on 16 and 4 on 16. The reason you need x times px is you add it all up to get the mean. What's the mean? 32 on 16, which is 2. That's why I need it, because this formula requires me to do the expected value of the x squared minus the mean squared. The sum of all these was 1. So now I do x squared times px. So 0 squared times 1 on 16 is 0. 1 squared times 4 on 16 is 4 on 16. 2 squared times 6 on 16. What's that? What's 2 squared? Do you know what I'm doing here? X squared. So 2 squared is 4. 4 times, yep, times 6, 24 on 16. Then we do 3 squared times 4 on 16. That's 9 times 4, that's 36. And then we do 4 squared, which is 16 times 1 on 16, which is 16 on 16. Now what do you get? Add them all up. Over 16, which is 5. So this, see this, 5, it's the expected value of x squared, because expected value means multiply the x squared by the px and add them together. So the expected value of x squared is 5 minus, what's mu squared? That mean is mu, so minus 2 squared is 5 minus 4, which is 1. Didn't we get variance of 1 before? So this is the alternative formula. This one's a bit easier. The two tables use the same data, and I worked out the variance. There are two formulas for variance. So my first one is to do x minus mu squared, times it by px for each of those and add them together, right? That gives me 1. The second formula is to do x squared times px, work them all out, add them up, and then subtract the mean squared. That's the second formula for variance. So I get the same mean and variance. I get the same variance using the two different methods. So there's two formulas for variance. Standard deviation and variance are linked. You've always seen standard deviation in stage 5. So standard deviation is the square root of the variance. Makes sense, because the variance is the squared. You know, to work out variance, we have to square everything. So standard deviation is the square root of the variance. It's usually assigned this pronumeral, sigma, just like that, which stands for standard. So the standard deviation is the square root of the variance. Or we could say that the standard deviation squared equals the variance. Because if you square both sides, standard deviation squared equals the variance. The pronumeral for variance, therefore, instead of using var bracket x, because the variance is sigma squared, because standard deviation is the square root of the variance, squaring both sides, sigma squared is the variance. So we could say that the pronumeral for variance is sigma squared. Okay. Standard deviation has the same units as the values, and so if your values are centimeters, then the standard deviation would be in centimeters. All right, so same units. And variance and standard deviation are measures of spread. Okay, an example here. 20 friends go out to dinner at a restaurant. One has $560 cash. 4 have $350 cash. 2 have $180 cash. 3 have $80 cash. 4 have $50 cash. 1 has $40 cash. And 5 people have no cash. And those 5 people that came with nothing wanted to borrow money off some other people. All right? Now, an armed robber bursts in and seizes one of the friends at random. She threatens him, so the robber's a woman, grabs all his cash and runs away. Find her expected criminal gain. So it's like, you know, on average, what do we think that this criminal is going to walk away with? So we've got all our different outcomes here, but we need the probability of each. Now, how many people are there altogether? 20. So what's the probability of that the criminal will get the person, one of the people that's got no money? Yeah, 5 people have no cash. Just leave it as 5 over 20. I mean, you can write a quarter, it doesn't matter. Then $40. One person has $40. So one person out of the 20. 4 have $50 cash. Are we good? And 3 have $80 cash. 2 have $180 cash. 2 out of 20. 4 have $350. And 1 has 560. Now before, 1 over 20, sorry. Before you continue, you want to make sure that they all add up to 20. 6, 10, 10. 20 out of 20, which is 1. So that's fine. Now, just follow the table. The reason, so x times px, that's just your expected value, which is mu, when you finish working it out. Is this using the original formula or the alternative formula? The alternative, the second one. So we're using the second formula here. It is a bit easier than the first one. Okay, so x times px, so you need to multiply each of those. 40 over 20. I'm just going to keep them all over 20. Actually, no, I'm not. I'm going to work them out. So just multiply them, and 200 over 20, is that 10? 240 over 20, 12. 360. Do you get 18 for the next one? I think you do. 700 over 2. Is that 335? Can someone just check my values? 56. 2 into 56. 28. Is that right? Is that what you got, girls? 2, 10, 12, 18, 35, and 28? Oh, well, maybe I'm making a mistake. Here, x, px, and then the sum of those, that is your expected value, or mu. So what do you get when you add all these up? 24, 140? So that is mu, or expected value of x. Okay? That's what that is. Okay, so that's your mu. We're going to use that. Notice this table doesn't have x minus mu squared, and it doesn't have x minus mu squared px. It's using the alternative formula. Okay, so this is using the expected value of x squared minus mu squared. That's the formula we're using for this one, the variance of x. Okay, so x squared px, you working those ones out? Someone tell me the values when you're done. So 40 squared divided by 20, I've been told 80. 50 squared divided by, times 4, what do you get? 960. Is that what everyone's getting? Next one? 24,500. Yeah. 24,500 and 15,680. Then we need a total. 44,960. Now that is your expected value of x squared, which could be written as the sum of x squared probability times the probability of x. Reason you've got a capital is because it's the expected value of all of the values of x that take on those values. Okay, so expected value of x squared and the sum of x squared px, they're exactly the same thing. They mean the same thing. Now what do I do? So I use my formula, which is expected value of x squared minus mu squared, or it could have been written as the sum of the x squared px's, that is the same as that, minus the mu squared. So what do we get? 44,960 minus 140 squared. And what do you get? 25,360. Now it's saying find the variance, which we've just found, and the standard deviation. So the standard deviation is the square root of your variance, which is the square root of 25,360. Like that. Which is what? Sigma. What is it? Girls, what do we get? Anyone? Okay, so the expected value, the expected criminal gain is $140 with a standard deviation of $159.25. In stage 5.3 last year, did you look at mean and how many standard deviations from the mean that you were? And you did Z scores? Did you look at Z scores last year? I'll just show you what this all means. The mean is $140, and we do something called, we look at how far scores are spread from the mean. So if the standard deviation is $159.25, if this is the mean, I'll just go X bar, but in our case it's mu. I'll just go mu actually, mu or X bar. We then look at the mean plus one standard deviation. So this will be 140 plus 159, which is what? 299.25 will be mu plus one standard deviation above the mean. So that's a mu. I'll zone in here. Zoom in. And then we can look at, now I know this doesn't make sense because we're going to get a negative here, but that's the idea. All right. Then you'd go 140 minus, but that would be a negative gain. Look, yeah, that's right. Some people had no money, but with probability distributions, but you're not going into that this year. All the data is supposed to be symmetrically, with a standard distribution, symmetrically centered. You can have symmetrical distributions around the mean, and there are percentages. We'll do them next year, but 99.7% of your scores are supposed to lie within 3 standard deviations of the mean. Okay, but with this one, it seems a bit strange that the standard deviation is so big, 159. But it's just an example from Nessa. We're just going to use any method you want to just work out the expected value and standard deviation here. So total number of cars sold next week is described by this probability distribution. We want to calculate or determine the expected value and standard deviation. Look, if you want, we can do both methods. What do you want to do? Do you want to try both? I think we should practice. Let's practice both and see if we get the same. Well, I'd have to do the other one somewhere else. So let's just do the x squared one first. And then I might put some more rows down here and try the other one as well. Okay, so what do we get? I'll just zoom in here a bit. Okay, let's go. All right, so you work them out and just look up occasionally to check, please. So just checking that all the probabilities add up to 1, otherwise it is not a probability distribution if it doesn't add up to 1. Then x times px, adding them all up, and what does that give you? What's the sum of all the x times px's called? The expected value, or mu. So what do we get for that? So that's mu, or the expected value. Anyone? 2.4. So let's do x squared px for this one. And then what we might do is do the other method underneath, and we'll see if we get the same answer for both. All right? So x squared px is 0. the same. 4 times 0.35. What's that? 1.4? I think it is. Actually, it would just be this value. 3 times 751. 2.25? Anyone? No. Yes. 3.2? I don't know. I'm just... You know why? Because this is x times px, and you're just multiplying it by another x. Well, it's that squared times the probability. Is that what you're getting, girls? All right. Now, just keep the bottom row there for a second. Leave some more room. What have we got for the sum of all those? The sum of all those is called the expected value of x squared. That's what that is. Now, if we use the easy formula, what have we got? The variance in x is, anyone got a total? 7. So the variance of x is the expected value times x squared minus mu squared, isn't it? That's the easy formula, which is 7 minus 2.4 squared, which is whatever. Now we're going to try the other method. 2, 4. So that's using the alternative method. In another color, I'm going to try the other method now. The alternative method. Expected value of x squared minus mu squared. Now let's try, I'm going to need another row, sorry. I'm going to do x minus mu squared, and then I'm going to do x minus mu all squared times the probability of x. Okay, so x minus mu squared, what have we got? That minus mu is 2.4. See how it's a bit messier? Because when mu's not a whole number, it does get a bit messier. It's much easier when mu is a whole number or an integer. But we'll just do it. 0 minus 2.4 and then square it. What's 2.4 squared? 5.76. This is a bit painful. 1 minus 2.4 squared. That's 1.4 squared. What's 14 times 14? 196. 2 minus 2.4, that's 0.4 squared, would be, please check them on a calc, 0.16. 3 minus 2.4 is 0.6 squared, would be 0.36. So you would not, so I'm doing this in red because this would not be the method you would go to when your mu or your expected value is not a whole number. It's not nice. The other way was, if you look at the first example we did, they were whole numbers. It's much easier. And 4 minus 2.4 is 1.6 squared. Is that's 2.56, I think. Is that what you're getting? And then add them all. I hope I'm right. What do you get when you add these? And then see how bad this is? This is really terrible. So you can see why we have the alternative method. Now what you've got to do is multiply this by the probability. So you see how horrible this is? The red method is not the preferred method. The blue method is preferred. When the mean is not a whole number, use the blue method. Got it? I want you to do it so that you'll never do it again. 5.76 times 0.05. Anyone? Or is it really bad? 0.05. Exact. And the next one, 1.96 times 0.15. Is it rounded? Is it exact? Oh, exact. 0. So you see, we don't want to do this, do we? We like the other method. Okay. So if you keep going, I've got the formula is, isn't it just this one? X minus mu squared, the expected value of x minus mu squared is here, where you multiply it by px and sum them. That's the expected value. Now, that's your variance. You can see why we have the alternative formula. So do not use the x minus mu squared method if the mean is not an integer, is not a whole number. Okay? because you can see it's extremely messy and a lot of chances to make an error.